In this video, we are going to see the calculation of drag force on a moving cylinder from the question of, with the help of a question from David Morin. So question is that a cylinder of mass m and radius r, it moves with the speed v from a region of space that contains particles of mass m, and those particles are at rest. There are n of these particles per unit volume. Number density is given. The cylinder moves in a direction perpendicular to its axis, and assume that small m is very, very small as compared to mass of the cylinder, and assume that particles do not interact with each other. Then what is the drag force per unit length on the cylinder? Okay, so let us see how do we solve this problem. So here what we are going to do first, that since cylinder is a massive object as compared to the particles, it is already given in the question. At some instant when it has a velocity in x direction, v velocity, then particles are at rest. So what we are going to do, that with respect to the cylinder, we are going to see that particles will approach the cylinder with respect to cylinder. So this diagram is in the frame of cylinder. With respect to cylinder, particles will approach with the velocity v, right? Because cylinder had velocity v. Then now, since it is elastic collision, then angle of incidence will be equal to angle of reflection because it is elastic collision. So the particles will move away like this. So this is happening in the frame of cylinder. Now, cylinder frame is an inertial frame because you can assume for this collision, the velocity of cylinder will not be affected much because mass of this is very, very large as compared to the mass of the particle which are colliding with this. Fine. So you can do the calculation. You can always do the calculation of force from any inertial frame. It will give you the same answer. So that is what we have done. So here now, this is the initial momentum of the particle. Again, with respect to the cylinder, we are calculating minus mv I cap. This I am taking as I cap. Final momentum will be what? This angle is 2 theta. So it becomes mv cos 2 theta I cap plus mv sine 2 theta j cap. Right. Now, one more thing we are going to see here, that change in momentum for the particle is happening in both x and y. But if you see that y component will be this way here, and a similar particle, if you consider here, then y component will be this way. So drag force, it's very easy to see that drag force is going to be in x direction. So we are going to focus only on the change in momentum in x direction. So P final minus P initial, if we do, then the J component I have not written. I've written only the X component. This minus this will give you this, right? So this I'm calculating for the particle, not for the cylinder. So this is for one particle. This is the change in momentum since cylinder frame is an inertial frame. So this will be the change in momentum in with respect to Earth also. Fine. Now, number of particles hitting in the area of theta to theta plus d theta range we are going to calculate, because this calculation is valid in a very small length here, theta to d theta, because theta keeps changing. So what we are going to do now, we are going to calculate, this is the momentum change of one particle. We are going to calculate number of particles hitting in 1 second. And then that is how we are going to get force dp by dt. So here I am calculating the number of particles hitting in the area of theta to theta plus d theta range. So this area you can see right here. So if you see from here, it will look like this, right? So this is the strip, length is 1 because it is given, you have to calculate the force on unit length. So I'm seeing from here, right? But now the point is that this is r d theta. But if you see the area swept by the cylinder in forward direction will be, for that what length we have to take? See this diagram now. This is r d theta, but we have to take the projection area, right? So that many particles are going to be swept by the cylinder. So this is r d theta cos theta. This angle is theta, and this is 1, right? So this is the area. In 1 second, this will advance by v because velocity of the cylinder is v. So number of, here what is written? Number of particles in unit volume. This is smaller given to us. And this is the volume swept by the cylinder in 1 second. So important point here is not to forget this cos theta. Okay, so now that's it. This is the momentum change of one particle. And these many particles are hitting the cylinder in 1 second only in this area, right? So force exerted in x direction will be dp by dt. So that is now, so let us see. So I have just multiplied this thing and this thing, right? That makes sense. Momentum change of one particle and then number of particles colliding in 1 second. only in this region. Fine. So df is equal to nr cos theta d theta b into mv1 plus cos theta, cos 2 theta. Then after that, you're going to get this integral cos 2 theta. I've written as 2 cos square theta plus 1. And now same thing what we are going to do, we are going to, because when cylinder is moving forward in this direction, only in this region, particles are going to collide. Due to that, drag force will act. So I have then integrated this from theta I've taken from here. So integrated from minus pi by 2 to plus pi by 2. And this now you know how to integrate. You can use the formula of cos cube theta, or you can just write cos square theta as 1 minus sin square theta and integrate, right? So that integration calculation I have not shown here, that you can do it by yourself. So force, drag force will be equal to 8 by 3 and m v square r. So this quantity is what? This is number of particles per unit volume. This is mass of one particle. So this is the density. Okay. So this is the force 8 by 3 eta m v square into r. It depends on the radius. It depends on the v square, right? And density of the medium, right? So that's it. That was my analysis. I think it is a very important question for JEE Advanced because similar questions on drag force have come, have repeated in JEE Advanced, right? Different situations. So I found this is a highly probable question for JEE Advanced. So please go through it once again carefully and focus on all the concepts involved. Thank you very much for watching. I'll see you in next video. Thanks a lot.